Okay. Last class, I announced we will cover this chapter 13, aggregate planning, maintenance, mathematical method example using transportation method of linear programming. First, I will briefly the background of this transportation method. Last time we did an assignment method. That case is like same number of machine and same number of like worker. So match one by one. At that time, the same number of machine and worker. So match 1 to 1. But transportation method similar. Usually this side is supply and then this side is demand or destination. So match supply to demand. In transportation method, the number of supply or number of demand doesn't matter. The amount is important. Match the amount. If demand is like 200 total, let's say 300. So like 100 need, 100 need, 100 need this term, this term, this term. Then if supply is surplus like 450, 150, 150, 150 like this, then supply is 450, not match. So to match, we need one more like a demand and a dummy demand. So make one more like dummy demand and then 150 like that. So in a transportation method, the amount should be matched. I will tell about this now with the example again. And then the same as assignment method, it need an objective function. If it is a minimum problem, then mean z equals and x11 certain like a, b, x12, c, x13, and so on like that. And then we need a constraint part. Constraint part is like this: available supply each term or from each source, and then so this one is x11, x12, x13. So x11 plus x12 plus x13 should be this amount, like 150 available source or supply. And this line, and then we need this demand and constraint, limited constraint. So x11, this one will be x21, x31. So plus x21 plus x31 equals this required demand, and so on like this. So this is kind of basic concept of transportation method. So let's go to example. Okay, this one. So this one from the example of our lecture last class. So the demand is in March, April, and May. Demand is like a forecasting demand is 800, 1,750. And then supply, available supply in March, 700 regular shift. And then if they do overtime up to 50, and then subcontracting 150. So demand in March is 800, but available capacity in March is 750, 900. So total 900 available. 1,000 in April. Here, same 900 available. 750 need. Here, 880 available. So total is 2,550 demand, but 2,780 available. So amount not match. Supply is more, so we need dummy demand. And then regular time cost $40 per tire, overtime $50 per tire. If we use subcontract like outsourcing, then $70, and then carrying cost $2 per tire per month. So using this information, we can solve using a transportation method. This one a little bit more complicated than assignment method. Okay, we need cost table, this one, and then this one is like an objective function cost part, and then here constraint part. So we need to fill out cost, regular time $40, $50 overtime, and so on. So type cost here. If we can download this example file from Moodle, then if we can do it together. So $40 and $50, $70 and $2 carrying cost. And then here, by the way, because available capacity and demand not match, So we need dummy column for demand side, unused capacity, like this. So we need one more column, March, April, May, March, April, May, same number, but we need one more unused capacity dummy column on demand side. So if, by the way, here cost, beginning inventory is 100, but the carrying cost is 0 because already this company has the beginning inventory. So cost is 0, type $0. And then if tire produced in March and then carry over to April, then $2 per period. So you can just type $2 here or copy using right click and copy and then paste, or you can type like this. And then here you can type $4 if carry like this, or you can use a formula equal this one plus $2. And then one thing, if I place cursor right after this cell number, then push F1, F4 function, then it change $, cell number with $, like this. Say again. If I click whatever cell, then it's type like a cell number, and then cursor is right after the cell number, and then click or type F4 function key, then it change with the $. That means this one is absolute value. That means I will test. If there is like 3, and then from 1 to 3, 1, 2, 3, and we need something absolute value. Let's say 4. So I need multiplication 1 times 4, 2 times 4, 3 times 4, like this. Then equals this one times this one, enter. Then if we copy using this dragging down, then automatically 06 times 04 It was 05, cell number 05 times 03. Copy using dragging, then automatically this one change, number change. But if I make it absolute value and copy using dragging down, then without $, change 5, 6, 7. Without $, the cell number change, but with the $, no change, stay the same. So we call this absolute value without $, that is a relative value. Change cell, then number change. Absolute value, even cell change, the value doesn't change. So I use that absolute value. Or here too, I can do it like this one equals the previous cell plus carrying cost, absolute value, change using F4 function key, then enter, then using dragging, copy, and change. The absolute value doesn't change, but without $, change. Oops, yeah, from C to D. And here, unused capacity, because it's kind of dummy, because unused, the cost is 0, and then we can use dragging down, copy, fold down like this. Okay, here, produce in March using capacity, and then use in March, then the same cost. So just copy, Control C, paste. Here the same, produce in March, April, and then use in April, same. So use Control C again and paste again. In May, produce and use in May, the same, like this. But here, if produce in March, use in April, then additional cost is carrying cost. So this one equals $40 plus carrying cost and absolute value. Using F4 function key, enter, change $40, $42, and then using dragging, copy. So $42, $44, and then this one, copy using dragging down, and and dragging, change it like this. So make sure $40, 1 month carry $42, 2 months carry $44, 52, 54, 72, 74. And then here, same, equals $40 plus carrying cost, absolute value, enter, and then dragging, copy. And here, produce in April, use March. It's not possible or not feasible. So, and then this one is the minimize problem. So, not to assign this cell or section, give big number like 9,999, because this cell, this cell not feasible. So not to assign, type big number like this. So now we completed cost table for objective function. Question? Okay.
No.
Okay, good. And move to the constraint part here. So using the demand and capacity information, column is demand. So first month demand. Before that, we need the constraint. So add or this cell, add or, okay, so equals sum of type sum, sum, then function, then dragging, specify the area, enter, then move cursor, do it again. So move your cursor right bottom, then you change like the plus sign, then move. Then here the same, equals sum of move cursor, enter. Okay. And here constraint for demand. Required demand is 800, 1,750. Type 800, 1,750. And then here later this one. And here beginning balance is 100. And March regular time, overtime, subcontract, capacity here. So 750, then 150. And next, April capacity was applied 750 and 150, the same. And then May supply 750 and 130. Okay. And then this one kind of surplus for dummy column. So total capacity minus total demand. So this is surplus, so equals sum of total of this one minus sum of total of demand, enter. Oops, okay. So surplus is 230. So this one should be 230. And then here, cost. Whatever cost, then assigned whatever here. So this one times this one, 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 and next one, this one times this one, and so on. So using sum product equals SUM product, sum product, double click, and then first area specify and then comma, and next area, and enter. So now is in the 0. And this table I just made, this one not related this transportation method of linear programming, but I made this one, so don't worry about this. So we're done preparing transportation method to use Excel solver like this. So make it smaller. Okay. Then go to data. And then server. Last time I told you if there is no server here, then using file options, add-ins, to change, then go, then you need check server add-in, then you can have server there. Okay, so click server, and then this one need objective. So we need this cell to calculate this cell using some product. So this cell, then changing variable cell. For calculation, we need change this section So specify, then I will delete this one first. And then constraint, by the way, we need a minimize the problem. So click min here. And then we need a constraint. Demand side constraint here. So this after change number, it should match with constraint. So add. Last time I said you can do one by one. This one equals this one equals this one. But we can do all of them. So specify all section we need, cells we need, equals here, and then OK. And then we need another constraint, supply side constraint. So this one equals this one equals this one, match. But we use all the section cells equals match it cells, and then OK. So first one is demand side constraints, and second one is supply side constraint. And then make sure simplex LP linear programming method to solve this problem, and all are OK, and then click solve. Changing this cell then looks OK, so click OK, then this one can be final solution. So in March, there is a beginning inventory 100 to match demand 800, produce 700 more. So 800 available, match it. And then in April, 1000 need. So in March, using overtime 50, using subcontract 50. And then in April, using a regular time 700, overtime 50, and subcontract 150. So 1000 for April demand. And the May demand is 750. So in May, produce 700 using regular time. Then using overtime 50. So total 750. So here, beginning inventory 100 in March, using regular 700, overtime 50, subcontract 150. So unused capacity 100. And April, using 700, regular time 50, overtime 150, subcontract, and so on. So match it 100, 100, 100, 700, and so on. So I made this table. So beginning is 100 in March, produce 800, 750 using 50 here. So 100, 700, 800. So use 800 and then carry over 100. They carry over 100, produce 900, to match 1000, and so on. So you have an assignment like last one. So assignment document, the Word file. Given the cost and the capacity, demand, similar, then 500 initial inventory, and then I made a tablet like this. So using this tablet, and then I uploaded instruction PowerPoint. Looks like this. So cell by cell, section by section, what you need put in. So follow this steps in instructions, then you'll be okay to do this assignment. Okay. Any question? And due is next Wednesday. Next Wednesday is due of this assignment. Okay. Okay. Oh, I used too much. Okay, today we will cover two chapters, chapter 16 and chapter 17. About just in time. Chapter 16, just in time, JIT and lean operations. JIT is just in time. This one is an approach of continuous and forced problem solving. Continuously try to find problem. What kind of problem? Like a cause of cost, or cause of unnecessary cost, or cause of unnecessary time. What is the cause of making low quality, like a defect, and so on. So identify problem, and then solve that problem, and then improve the process, and so on. So you try to find the problem and then solve to produce more with less inventory. So try to reduce inventory or inventory cost. And JIT system is pull system. Just in time is pull system, and this one is make to order system. So nothing will be produced until it is needed. So when customer place order, then start this process or system, and it is pull system. Pull system is inventories are pulled through the system by actual demand, make to order system. Okay. I need both. Okay, then why it is a pull system? I will show you. Customer ask, place order, change color, better colors, okay, that red. Customer place order, but because this one is make to order system, this one doesn't have final product, so this one has product, component, whatever, and ask, then send, and send like this. So asking, I need a part, I need a component. So it is like a pull the inventory or part. So in make to order system, inventory, not push, is pulling. So pull inventory or part. So we call this as a pull system. And push system, we did an MRP system, and traditional conventional system is make to stock system. Make to stock system, by forecasting and by due date, just make and then stock. So forecast future demand, change color, future demand, and then just make and then send it down to next and next, and then inventory somewhere, then when is needed, send like this. So in make to stock system, inventory or parts just push down to next station or work. So conventional system, traditional system, or MRP system, use make to stock system, and then that is a push system. Anyway, JIT system use make to stock, make to order, and pull system. In JIT system, three things are fundamental issue: waste, variability, and throughput time or throughput rate. Waste. Waste is anything that does not add value from the customer point of view. So unnecessary things, unnecessary process steps, unnecessary space, unnecessary inventory, unnecessary act, and so on. So everything not value added activities or things are waste in a production system. Owners 7 waste Toyota system identify 7 waste like this: overproduction, such as overcapacity, over amount of production, and then Q, kind of waiting, and transportation, long transportation, that can be waste, and then inventory, unnecessary inventory, and then unnecessary motion, kind of activity or unnecessary process, and over process, unnecessary process, and then defective product, scrap, and so on. So they are kind of waste. So in JIT system, try to eliminate these kinds of waste. And then variability. Variability is any deviation from the optimum process. Optimally, like a demand, demand. If demand is optimal demand is like this, or optimal capacity is like this. But because of the demand change, to match the demand capacity change like this. So, or optimally, we need like a throughput time is 10 days. But because of malfunction of machine equipment, or the delay from suppliers, so throughput time, the production time vary. That can be a kind of variability. So unnecessary things, because of variability, that also waste. Source of variability, poor process resulting in improper quantities, late or non-conforming units, such as defect, delay, and then the amount different, and so on. And inadequate maintenance, because of not proper maintenance, the machine malfunction, and so on, and then a delay. Unknown and changing customer demand can be cause of variability. Incomplete or inaccurate drawing, specification, or bill of material. You know, bill of material, the structure of final product and components. So incomplete or inaccurate specification, like we need 1 inch, but inaccurate drawing or specification like 1.1, then it can be cause of defect and so on. Inventory height variability. If inventory level is not too high, then variability there, whatever cause, like a scrap, setup time variability. If we have enough too much in inventory, then we cannot see that variability. But inventory level is low, then we can see variability. And less variability results in less waste. So in a JIT system, try to eliminate this variability using whatever tool or technique. And throughput time or throughput rate, each wasted time products are in the process cost accumulate and then comparative advantage is lost. So waste time because of whatever cause, delay, or making a poor quality product, then the company can lose comparative advantage. And then usually in JIT system use pull system. Sometimes pull system increase yes, using a pull system increase throughput rate, increase the production rate rather than push system. So using a JIT system, use pull system to increase the throughput rate. And pulling system, pull system can reduce inventory level. Then cycle time can be reduced. Okay, using JIT techniques with the suppliers, make a closer supplier relationship, and then JIT layout. We will talk about JIT layout later. Then try to reduce inventory and scheduling better, then reduce time, and then use preventive maintenance, then quality production, increase quality, and give employee empowerment, and then commitment. Then waste reduced, and then throughput time increase, and inventory level low, and so on. Then finally, the company can get achieve comparative advantage. So we will talk about what kind of JIT techniques to reduce or eliminate waste and the variability, and increase the throughput rate or decrease the throughput time. Toyota system is the most famous JIT system. And Toyota JIT system, they call TPS, Toyota Production System. And in Toyota system, they try to solve a problem continuously using JIT concept and eliminate excessive inventory and eliminate waste. First, Toyota is using focus factory network. I've never been a Toyota plant, but I know about Hyundai and Kia. In many times I mentioned about Hyundai plant. So Hyundai is in Montgomery, Alabama. It's in Montgomery, Alabama, and then somewhere south part of Montgomery. And then this is I-65. Then about here, I-85. Then here, Alabama and Georgia border, and then Kia here, Hyundai here. And then many suppliers of Hyundai and Kia near Hyundai, somewhere here, somewhere here, like this. So they suppliers between Hyundai and Kia, they send like this. Then mostly from near Hyundai, then for Kia, like this. So it looks like network. And then focus on factory network. These are small specialized plants that limit the range of products produced. Sometimes only one type of product for an entire facility. I know I visit many supplier plant there. One supplier and the other one connect, and then Hyundai here and connect like this. This company produce circuit inside of door panel, like a switch, the door and certain the function key. So this company produce circuit board put inside of the door panel, and then this company produce door panel. So this company produce circuit board and send to this company, and this one produce door panel, then attach that circuit board, and then send to Hyundai. So many companies like that. So produce connected, maybe sometimes directly Hyundai, then each other, something like that. So they produce only one type, sometimes two types, and so on. So they are connected and looks like a network. So we call this focused factory network. Why they use this focused factory network? Reduce distance, the delivery distance, and then time, lead time. So reduce lead time and delivery time and so on. So by using this focused factory network, they can reduce unnecessary time. So there is focused factory network to eliminate unnecessary waste time. And group technology, we talked about this group technology earlier when we covered layout. So using this group technology, we can make a cell. So without cellular layout group technology, the moving part or component process, moving distance is long and then complicate. So using a cell or cellular layout by group technology, then the part component moving distance is shorter. So using this group technology and a cellular layout cell in JIT system, reduce unnecessary distance, unnecessary time. And quality at the source, inspection at the source. It's like from suppliers to a main company, send, part, receive. They produce and then inspect. Then 100% sure, then send. And then this receiving department or section trust the suppliers product quality, and then without inspection just use the part for a process or production. The same, produce and inspect and then send. Produce, inspect and send. So if we can use this quality at the source or inspection at the source, then we can reduce inspection time. We call this lean quality, use statistical process control. We will talk about this statistics SPC later, in later chapter. Empower employees, give the employees decision authority. If they find something, then they can do themselves. And then fail-safe method. I think you remember Pokayoke. Fail-safe method. And then using in a JIT system, usually smaller size. So expose poor quality with smaller size. If we use larger size, then if we find something wrong, then the large lot just get rid of. But if we use the smaller size, find something problem, then we can quickly handle that problem and provide an immediate feedback. So if they find something wrong, and then feedback immediately to make it better using this quality at the source. Uniform plant loading, in Japanese, heijunka, or we call this, we can, another name is level scheduling. Scheduling first month, schedule 50, second month 100, third month 150. Then need 150 capacity, but if we can schedule using level scheduling, like total is 300, can divide by 3, then equals 100 each. So schedule 100, 100, 100 like this. Then we can make even capacity. So that case, 50 is unnecessary capacity. So smoothing the production flow to damp the reaction waves, make it smooth like normally. And then setting a firm monthly production plan and then froze. That means like a 1 month, usually production system has 1 month freeze window. So whatever demand change or like 1 month, if the production schedule here in 1 month, don't change, just produce as it is. Earlier than like 2 months earlier, 3 months earlier, they can change, but use the freeze window of 1 month or 1 week and so on. So that is uniform plant loading. Then we can reduce or eliminate unnecessary capacity. Okay, then Kanban system. In JIT system, we can use the Kanban system to reduce delay time by waiting time and so on. Kanban means sign using instruction card, container, Kanban square, and so on to signal the need for production of a part. It's like we'll change. Kanban system is like a signal system between stages, maybe kind of buffer Kanban container. So at the beginning of the process, this container full. So using this part, this stage produce, while it's produce, then this one fill, this empty. And then when it's empty and then there is no sensor, then send the signal. We need part, we need part. After fill, then this one fill this one. When it's filling, then this one use this one and so on like this. So this is the Kanban system. In my home, I use this Kanban system. Water dispenser. Actually, inside of nowadays, inside of that water dispenser, like hot water and cold water inside of this water dispenser, the 5-gallon water. So there is no water. I have 2 bottles. So when it's empty, then out. So empty bottle, and then one is in. So one is inside there, one left. And then when this one empty, and then another come out. And then this one inside. So it is sign like there is no water bottle here or two empty water bottle here. That means I should go to buy water. So this is my Kanban. So using Kanban system. And then, the drive-through like McDonald's and so on. Then certain drive-through has only one window. It's like a building, and then only one pickup window. So order, drive, and then order, and then approach to this pickup window. But certain fast food restaurant has two windows, and then here drive in and then place order, and then they said first window to pay, and then after pay, then the next window, and then pick up like this. So this is kind of the Kanban system. One window, usually it is not a Kanban system, but two window they use, and this one is kind of Kanban system. Order, and then pay. When is pay, when is order, then send order information here and then here. So it's the sending sign, and then after pay, move. This is one of the Kanban example. So using Kanban, we can eliminate out of stock, out of the part. So make it the process smooth. So reduce the waste, kind of waiting time. And then minimize setup time. Setup time is waste time if they can reduce or eliminate setup time. So using like a separate process or assembly line for each different types of product. So if type A, type B, then using one production line or assembly line, type A come and then type B come, then they need a setup. Or then like AB, then duty setup needed, but change the schedule, AABB, then only one setup, so we can reduce setup time by better scheduling, or using separate A, B, so A come and then send it to A, B come, send it to B, and so on. So using a separate line, then we can eliminate a setup time, or using like a cell, then a better process design, then A and B common process, and then send A here, and then send B here, and then out. like this, then we can reduce or eliminate setup time. So many methods to reduce setup time or minimize setup time. Then we can reduce throughput time, total time. Oops. Okay. Then next, lean layout. For the JIT system, layout is important. So try to use link operations. So build work cells, then make they link together, then reduce moving distance and then time and so on. And then balance workstation capacity. So each workstation capacity same, then the unnecessary capacity reduced. And redesign layout flow. So using link operation or line type, then try to minimize distance, moving distance. And then use preventive maintenance to prevent the waste time by malfunction and so on. And then build flexible or movable equipment. Then we can reduce setup or changeover time. So, and then reduce lot size. JIT system use smaller size. To use a smaller size order system, the focus factory network is necessary because order small by small, then distance, delivery distance or lead time shorter, then JIT system use smaller size order system. And then in JIT system, the partnership or relationship, close relationship with the supplier is important. 4 goals of supplier partnership are remove unnecessary activities like long distance, then short distance, and remove or implant inventory closer using a focus factory network, closer suppliers, then reduce inventory, and then reduce in-transit inventory, and then improve quality by using quality at the source. Then finally, using many techniques, concepts, then finally, they can use the right amount and the right time. So if I need 100, then receive 100 when I need. Then using a smaller size, then the inventory level low, and then waste eliminated. So that is the JIT system or JIT production, lean production. When we say JIT lean production, they should be right amount, right time, smaller size, then virtually no inventory. Okay, that's all chapter 17. Let's take a 5-minute break and then continue chapter 17. Chapter 17 is not too long, but I need a 5-minute break. Okay, I will be back 7:25. I'm back. Okay, chapter 17 is about maintenance and reliability. In JIT system, maintenance is important to reduce or eliminate unnecessary time cause of machine failure. The objective of maintenance and reliability is to maintain the capability of the system when they need the machine work. So maintenance is all activities involved in keeping a system's equipment in working order. So whenever need machine, it work. Reliability is the probability that a machine will function properly for a specified time. This time, because of and also this class is online, and then this time because of pandemic, coronavirus pandemic, even I teach in class face-to-face. I don't give a student the printout, but a regular time, if I teach face-to-face class, then I make a lecture notes, copy, print out, and then make a copy. Our schools, especially our department copy machine is old. So many times didn't work. So we need a new copy machine or maintenance well to increase the reliability. So many cases I couldn't make a print and I couldn't make a copy. So I bought my many when I work at other university, they give faculty members their own printer. So in case the copy machine doesn't work, then we can print out using our own printer. But our department didn't provide own personal printer, so I bought my own printer. So anyway, maintenance is important to increase reliability. So maintenance management. So all employees involved in maintenance. So partnering with the maintenance personnel. If they have like a maintenance department, then personnel maintain the machine. So when I was in Alabama, Montgomery, Alabama, then Hyundai, I know many Hyundai people, and then suppliers. One night, they go to work, even it's at night, to maintain their machine. So certain night they like clean and maintain. And then skill training. Like our department copy machine sometimes jam. Then if we can handle that jamming myself, then we can use that copy machine solve that kind of problem ourselves. So we need a kind of training. Certain symptom, then use this solution, then fix that one and like that. So, and then sometimes the reward system need, and then employee empowerment. You know, we have an IT help desk. So computer at school problem, then ask help desk, then they come and then fix that problem. But if I have kind of authorization, then I can fix whatever problem because I have a skill to fix that problem. But because I don't have that authorization, so I cannot fix my computer when something problem. I should ask the help desk. And earlier, last year, I asked the help desk to install something, program, a computer software program. And they said, no, you cannot get that authorization. So if I have that authorization to install something or fix, then I can do it. But every time I ask help desk come and then install that program in the computer lab computers. So just like that. So sometimes we need an empowerment. And then maintenance and reliability process, clean, lubricate, monitor, adjust, and so on. So using a certain protocol or procedure. So with well developed procedure or protocol, and then with an employee environment, then we can reduce inventory, improve quality, and then reduce certain unnecessary time and so on. And types of maintenance: preventive maintenance, breakdown maintenance, and predictive maintenance. Preventive maintenance is a routine inspection serving with keep facilities in good repair. So if we expect that like machine failure or malfunction, so like every week, every month, so schedule routinely maintenance, then we can prevent kind of malfunction, breakdown. And then breakdown maintenance, when is malfunction or when is occur problem, then go and then fix it. That is breakdown maintenance. And predictive maintenance, using advanced technology to monitor equipment and predict failure. You know, our car nowadays many advanced technology. So certain like a warning light. Usually, warning light is yellow. Something break down or happen, then red color. So using yellow give warning, then like using sensor. So using technology, and then predict a certain problem, and then fix that one earlier before a problem. So 3 types of maintenance, and compare breakdown. advantage, no prior work. When it happen, then fix it. Preventive work can be scheduled. So schedule like every week, every month, every quarter. And predictive using technology before something happen, catch that cause or something, then fix it. Disadvantage, breakdown, then maybe something happened like injury and so on. And then preventive schedule, so need labor and cost and so on. And then predictive need an equipment, so that also cost. And then resource, when it's breakdown, the worker come. So when it's needed, then worker and time need. And then need like every the scheduled time. They need labor and then part and so on. And then predictive need technology equipment such as a sensor and so on. So like office and a copier, like I mentioned, our department copier, when it's breakdown, then fix it. And then in manufacturing plant, machine, they need the schedule and then clean, lubricate, and so on like that. And then this one, such as our car and so on, predictive. Reliability. Total the system reliability depending on each individual, like a machine or equipment reliability. So to improve system reliability, we should improve each individual reliability. So it's like that. So first, machines reliability is 90%, 80%. The second one, third one, 99%. Then system reliability is first one times, second one times, third one. So system reliability is 71.3. So improve system reliability. We should improve individual, machine, or equipment reliability. So number of members or machine, more machine or more equipment involved, reliability drop exponentially like this. So if we can reduce the number of machine or equipment and then improve individual machine or equipment reliability, then we can improve system reliability exponentially. Okay, to improve reliability or better maintenance, we need well-trained personnel, and then we need a better adequate resource, such as equipment and sensor and so on. And then ability to establish repair plan, schedule, priority, which one first, second order, and then authority. So given employee empowerment, the ability to identify the cause of breakdown. So well-trained personnel, then trained well, then improve the ability of identify cause of breakdown. And then using MTBF, mean time between failure. For our department copy machine, like in the history, last year, 20 times problems. Then 1 year, like 12 months divided by 20 times, then a certain day. So that is MTBF. So schedule the mean time, like the calculate again. Make it simple. Like 12 months is last year. And then if the problem occurred 6 times, that case, so divide by month, and then how many times? So that will be 2. So every 2 months, the problem can be occurred. So schedule maintenance every 2 months, every other month maintenance. Then we can reduce the breakdown delay because of the breakdown. So using MTBF schedule the maintenance, like a preventive maintenance, then we can increase repair capability and so on. That's all for today's lecture. Okay. Ooh, kind of a long night. Do you have any question? No. Okay. Other than the chapter 13 assignment, the transportation method using the Excel solver, no assignment from chapter 16, 17. So that's all, and see you next Tuesday.
Okay.
And good night.
Thank you. Have a good night.
Thank you. Have a good night.
Good night.